the chapter that we started last night, and this module B, and then this is 8. We'll finish this one, do 9, have some lab time, please work on the labs. And tomorrow night we'll do 9 and probably 9, 8, 9 tonight, do 10 and get started on 11. I'll get my numbers straight here in a second. And then finish up 11 and then have the end of course things on Friday. You're supposed to get an hour to do the end of course assessment, and then you do the evaluation. It's a half hour for it. So I try to finish up with my portion around 8 or 8:30 so that you have the designated time to do those things. It's not going to take you, it shouldn't take you an hour to do any of those things, but the timer on the assessment is for an hour. So that's what you're supposed to get for that. So anyhow, we're going to talk about point-to-point protocol, authentication systems, and then network authentication systems and some protocols, some authentication protocols in here. Authentication systems secure resources or restrict access. An authentication server, we have a number of them. Radius is one, remote access dial-in user service. TACACS, which I won't even try. It's a Cisco proprietary one. And Active Directory, the one that we use a lot in our networks. Probably what you're using there is an Active Directory logon to get into get onto the workstations. So what they do is authenticate remote connections, the secured connections across the unsecured network, then authenticate users joining the LAN or the wireless LAN. Nothing really magic there. Authenticate when we prove who we are, whatever process we're using. We can also have authentication between devices, and that's what point-to-point protocol is doing here. I have a flow chart here that we have no links between the devices and a link establishment, a physical link, the link control protocol link, and then authentication. If authentication is configured, it doesn't have to be. But if you have 2 routers and you don't want somebody to be able to put routes into your system, you can cause them to authenticate to each other before you do that. And then the authenticated link, the network layer. What it looks like, and I'm going to drag this over, this is the whole thing. This is actually a point-to-point protocol over Ethernet and all the stuff that was going on. But when we just look at the point-to-point protocol portion of this, we'll go up to the top here. We have a configuration request, a PPP, point-to-point protocol link control, the LCP, the link control protocol. Configuration options here, it's negotiating the link. The magic number, which is kind of a mystical sort of sounding thing, is simply a random number that's generated on the device so that they can keep each other straight. If the magic number keeps showing up that it's negotiating the same magic number, that you may want to look and see if it is in a loop of some type because it's getting its own back. Some more, we have the authentication protocol. We have the magic number, challenge handshake authentication protocol. We have the algorithm here, CHAP with MD5. When we do that, we have this was getting the connection established. Then the challenge handshake authentication protocol, which a challenge gets sent to the other end, and when that challenge gets sent to the other end, the challenge gets encrypted by the password and goes back, and then it gets decrypted. And if we get there, then it works. If we don't, it doesn't. And here we have CHAP. The challenge got sent, the code challenge, the identifier, the data goes back. We have the name here is R2, and that was the name of the router. And then the value here, the hashed or the encrypted, this one's actually a hash of all of the information goes back so that they can do the authentication with each other. And then we have success, and yep, now we've got success we have the authentication. And then we have some configuration requests here. The IP control protocol, similar to DHCP. It negotiates the IP addresses for these things. CDP, Cisco Discovery Protocol. We got a reject in here, configuration request, and then I think one of them is that we have one of them. I thought was one of them is the .254, and the other one was the .1 address. Once PPP gets established, the point-to-point protocol gets established, it uses ping to be sure that the connection still exists. The echo request and the echo reply between these two to be sure that the other guy is still there. So it uses those types of things in order to do the establishment, to be sure that it is still there. The thing here, we authenticate. It has a lot of things going on. It's a layer 2 protocol used for wide area network, usually serial links to go from one location to the other. Unsuccessful, then the link is going to be down, and the link termination, the link failure, the link closed when we get done with the connection. But the startup process, the negotiation process for point-to-point protocol. And here, point-to-point protocol has a number of things. We have the net control protocol, network control protocol, the NCP, which we saw, the IPCP, the IP control protocol, and underneath it, the point-to-point encapsulation, point-to-point protocol over Ethernet, and then over ATM. It's used with Ethernet. What that means is one of the protocols gets encapsulated into the other protocol. We use Ethernet as far as Ethernet will go, and then once it gets to the point that it needs point-to-point protocol, it gets de-encapsulated and uses that information. So a number of things going on with this PPP encapsulation, point-to-point protocol, point-to-point over Ethernet, NCP, network control protocol, IPCP, IP control protocol, all parts of the PPP. The authentication, different ways to do the authentication, and the one at the top there, compare values, a logon request. The challenge gets sent, encrypts the value, it encrypts the challenge with the password, and sends the response to the server that decrypts it, and then once that happens, we have the session established, and a secure session established. Now, these are not encrypted transmissions. The only thing that's encrypted is the password for the authentication. The password, or the password protocols here, PAP, Password Authentication Protocol, really old, really insecure. Everything is clear text. So if you're running Wireshark and you have a PAP password going back and forth, and anybody that can see it's going to be able to do it. It's better than nothing, but not a whole lot. But it is a little bit better. Challenge Handshake Authentication Protocol, CHAP. Somewhat secure, but it is vulnerable because there's no mutual authentication. And the one up here, we can have it so that each of them logs on to each other, but there's no mutual authentication. One authenticates to the other. We can have it one way or two way, but the process at the top. MS CHAP, Microsoft CHAP, is the next iteration of CHAP, the Challenge Handshake Authentication Protocol. Not necessarily really secure, but it does have mutual authentication. EAP, the Extensible Authentication Protocol, we're going to look at as we go through, and I think it's in this one, the process that use. Extensible means that we can add it to the operating system. Windows 2000, I think, was the first Windows one that had extensibility or extendability built into it. It allowed us to do these extensible EAP down here, TLS, Transport Layer Security, SIM, WPA Enterprise. All of these things can be there. It's a message format that it supports. PEEP, password extensible authentication protocol is one that's used in 802.1x, for instance. It creates a secure connection to, like we saw a little bit earlier with the tunnels, the IPsec, two steps. One, we set up a secure tunnel to do the negotiation, and then we have, after the negotiation's done, we figure out which protocols are going to be used to actually encrypt the data. That's where we are with the extensible. The extensible just adds to it. EAP, we have to have the ability to do that. The message format supporting a wide variety of authentication methods, a framework, if you would. IPsec is a framework. IPsec, we had a framework. We add the hashing algorithm, the encryption algorithm, and the key exchange, the Diffie-Hellman, or whatever we're going to use for key exchange in those, are added to the softwares we have. The EAP, Extensible Authentication Protocols, TLS, TTLS, use X.509 certificates, SIM, the SIM used by the GSM cellular networks, the SIM card. We're talking about the SIM card that's in your device. Authenticates the devices using the SIM cards. WPA Enterprise uses extensible authentication protocol along with the 802.1x standard for authentication. And in the share site, in the Blogspot site, I think I've got a link to a, if you're interested, how to configure 802.1x for a wireless access point. I'll look at it for in Packet Tracer for a wired. Packet Tracer demonstrates what you have to do, but you don't get things like, oh yeah, I really got to have a certificate. And certificates were the ones that always drove me crazy doing that. Its problem, the 802.1x, is a one-way authentication. The server authenticates to the client, but the client never really authenticates to the server. The individual authenticates by using the username and password, and this is another one. The 802.1x typically is going to use a Radius server in order to maintain a username and password list. Extensible authentication protocols are what allow us to use the smart cards, the iris scans, and the fingerprint scanners, and all those other updated, I guess, authentication methods. LEAP, Lightweight Extensible Authentication Protocol, Cisco proprietary, based on MS-CHAP, was in early Wi-Fi devices. More secure methods are used now. It just keeps showing up in these things. I think they just like the abbreviation LEAP for these things, but Cisco doesn't use it. It's really not used anymore. EAP, Extensible Authentication, Fast, Flexible Authentication via Secure Tunneling, a mouthful. Newer replacement for LEAP, stronger security, keeps the lightweight access. And then PEEP, Protected Extensible Authentication Protocol, isn't a method but a protocol that secures the authentication in the TLS tunnel. It creates the tunnel before any of the processing takes place. So a number of different extensible or extendable protocols. Radius, Remote Access Dial-In User Service, is used for point-to-point protocol, wireless. A lot of different authentications can use Radius server. Let me try a Packet Tracer here, see if I've got a Radius server. I've got a number of things that use Radius server. Let's see, no. Well, I could go back to the one that I had. Yeah, they kill me too. Radius has been around a long, long time. Radius was, as far as I can tell, was used during the dial-up days. What it allows to happen, and I'll just drag this over so that I'll scroll on it. What it allows to happen, and this is 802.1x, which we can look at while we're here, is in this case, when these machines want to log on to this device, they send a username and password, and we do use a username and password, to the switch. The switch then sends that to the server here, which is the Radius server, the authentication server. The Radius server could be a TACACS or Cisco. Could be, what we have with Radius is it can get its information from Active Directory, which is a lightweight directory, which is an LDAP database at its heart, which uses port 389. We'll get all that stuff in here right now. So the switch here sends the information to the server, the Radius server. The Radius server then goes back with a yay or a nay. And in this case, the one is you see it's green, the one is a yay, and the other one is a nay. It doesn't secure, no, it doesn't secure the whole authentication process. TACACS secures the whole authentication process. Caesar's absolutely right. But the problem with TACACS is, although you can get some, there is a place on the internet you can get a TACACS if you want to configure it, but the updated TACACS, Cisco proprietary, typically what we're talking about here. Radius is UDP, TACACS is TCP. This secures the entire packet. And this one's going to protect our username and password. So some configurations, a little while we're here, talk about Radius for a couple of seconds, since Raphael kind of did and kind of didn't. But we look at the desktop, and I'm going to go to, I'm going to go to services here, and I'm going to go to AAA server. What you have to configure on the device and on the server is a client name. We have the name AAA, and it doesn't really matter what the name is, but the client IP. The client is the switch. The device is trying to get authenticated. The server type is Radius. The key, this is a pre-shared key, a secure key, so that each of them can know that they're talking to the right device. You know, these are pretty straightforward, pretty easy. Then the username and the password that's configured on this one of them is class and class, and these are obviously just for demonstration purposes. When I go to the switch, and don't get taken or hung up on the configurations, I have to tell it the switch that it's using, in this case is .1x, and the default group is Radius, and it's using the Radius server for authentication for the 802.1x protocol. And we'll cover, we mentioned 802.1x, might as well talk about it while I've got this going here. On the switch ports, we tell it to use 802.1x for the authenticator. What we're doing on the switch is the port's not going to become active or authenticated until the user authenticates to the Radius server. The last thing we down here is we have to specify the Radius server. Its IP address, the port it's using, 1645, and then the pre-shared key here for Cisco. So when I go back to my workstations here, one of them is and one of them isn't. The one that is, if we go in here and look at his NIC, and this is one of the really kind of hokey things about it, use 802.1x security. There are clients that are on the systems now that can use this and put the username and password in, and it will eventually turn the port on. This guy, not there yet. We can go in here and in its NIC, we can do this and use class, right? The username and password. And it's going to go through, so this takes a couple of minutes. It goes through an entire process, a pretty long process, in order to, and now we're up, in order to allow the port to become active. So if we use 802.1x, and we can use it on a wireless or on a wired network here, not a really onerous configuration for it. We can make users log on to the network, and the Radius server can take its usernames and passwords from Active Directory. So it's not like I've got an Active Directory domain and now I'm going to have to put in all these usernames and passwords for the entire domain. That's not the case. Radius can use that LDAP database. So until they can log on with a valid username and password, they can't get an IP address. So there are a couple of things in securing switches. We talked about port security, where we basically did MAC address filtering. We looked at the sticky addresses that were part of the configuration, sticky, stuck to the ports, that only those MAC addresses, just like you might do MAC address filtering in a wireless access point around a wireless router, we're doing MAC address filtering, as well as only authenticated users can get an IP address. So a couple of different ways to do security on a switch, the low layer 2 switch, which, for the longest time, I thought all you did was plug stuff into it. And then I found out that, hey, you can configure a number of different elements of security on those things. So Radius, remote access dial-in user service, was designed for dial-in. Used for point-to-point protocol, PPP protocols, as well as wireless networks, as well as we can use it for the 802.1x there. 802.1x does use Radius typically for its authentication. Client-server system. The client is the remote access server, not the user workstation. This is just terminology. So the client is actually the device, and then the one that we showed in Packet Tracer. The client would be the switch, the device that's asking the authentication server, is it okay to let this other device, or to let this user, in the case there, to activate the port. PPP protocols are used for relaying the credentials on these things. The Radius authentication, and I guess we kind of saw that, or at least we've kind of talked about that. In this case, the NAS, the network attached storage unit here, the user goes to the network attached storage device. The NAS sends the request to the authentication server, Radius server, evaluates the credentials, replies to the NAS, and the NAS either sends an accept, a reject, or a challenge. And the challenge may ask for more information. That more for the to assure the system that you are who you claim to be with these things. TACACS, and now you know why I didn't try TAC. Terminal Access Controller Access Control System. Advantages over Radius TCP rather than UDP, so it's going to be improved scaling. We also are going to have confirmation of the transfer of the information. More complete encryption is available. Fully separates all 3 AAA steps where Radius doesn't. Supports non-IP protocols. AppleTalk, Novelnet, BIOS. And again, the supports non-IP protocols used to be a pretty big deal, because we had NetWare had a proprietary protocol. Some people were using AppleTalk, although I'm not sure they've done that in a long time. AppleTalk tends to be pretty slow. Apple uses IP. NetBIOS, Microsoft NetBIOS broadcast protocol. So each of those could be used on a TACACS server. IP is what we're talking about for a Radius server. Disadvantages versus Radius. Resource intensive. It's proprietary. Cisco, although there are some iterations of Radius, and again, if you want to play with it, and you probably wouldn't until you get to Cisco, you can get one, you can download a free one, and it's a pain to configure because it's a not, full-blown clicky Radius server. Primarily intended for network devices. And diameter is the third option. And their thing, and it's a new one, a diameter, they say since it's diameter, it's twice as good as radius. I don't know, I've never used a diameter. I've used the other two a little bit, radius more often than TACACS. RAS, Remote Access Service, is a Microsoft thing, and my machine restarted on me. I need to get connected here. For my remote, and we'll look at what can be configured on a RAS. Used by Windows Server, directly authenticates the connection. Routing and remote access service includes a routing capability and allows Windows to act as an ISP. It actually allows it to act as an endpoint. So, there it is. When I look at this thing, routing and remote access, this one isn't configured. Can't make the fonts any bigger. I apologize for that. But we can go in here to add server, refresh. Well, let's do a configure. That would be a good thing to do. So when we configure it, we can configure it for remote access, dial-up, or VPN. If we had, and this still supports dial-up, if we still had a modem bank. NAT, network address translation. VPN, access, and NAT, secure connection between two private networks. Connect this network to a remote network, such as a branch office. So we're talking about connection between two private networks. We're talking about VPN here, tunnel mode. Or we can do pick our own. We can do VPN access, and we probably don't need. Let's do NAT and LAN routing. When we do those, it should then add those services so that we could configure them. So we can make this an endpoint to allow connections from outside, VPN connections. We can use it to NAT. We have ports here. The network interfaces, and I don't have enough to do routing because I only got one real LAN here. And the ports that are available, and these are the WAN mini ports. So SSTP, these are going to be for the VPN, the protocols that are used for the VPN. So we can have these number of connections on the VPN to do those. So routing and RAS, or remote access server, uses the routing and remote access, another acronym for you, Raphael, in order to do those things. So it adds those, and then not to be confused with RDP. RDP is what I am using to get to these things, remote desktop protocols. I'm connected to another machine. This is another Windows 10 machine. It's sitting behind me. I'm running the virtual machines on it because of the number of resources that all the other stuff that I'm running takes on the machine that I use for the class. So not to be confused with RDP. 802.1x, we looked at kind of what it is in the wired world and looked a little bit at the configuration of the switch. The process itself here, the EAP OL, Extensible Authentication Protocol over LAN, start. What's supposed to happen here, and then it says a request, EAP request identity. What is happening here is the workstation is telling the device, hey, ask me for my credentials. That's what this start frame is. What ideally would happen is when we connect, it's going to send us the request identity. If it doesn't send us the request identity, we say, hey, ask me. Ask me for my information. When that happens, the EAP response identity, which then gets sent to the Radius server, the access request gets sent to the Radius server. The Radius sends the challenge back, the OTP, one-time password, EAP request, the challenge goes back. Then we have the response that comes back. We encrypt the challenge with the password. And you kind of saw what one looked like in the PPP exchanges that we had a few minutes ago. The access request, and then we get either an accept, we could get a deny. And then once that happens, the port is authorized. Or if we're doing a wireless access point, then we get access to the wireless access point or to the wireless router. When we get done, the EAP OL, Extensible Authentication over LAN log off, and then the port becomes unauthorized when we log off for these things. So we have the supplicant, which is what we would usually call the client, and then you get to reading the resources or reading the books, and they start out and say, oh, this is a supplicant, and then later they start calling it the client also. And then the authenticator, and this would be the client in the proper terminology. The network resources, and then this would be the authentication server, the Radius server that we would use to allow the port to become active over here on the device. So the 802 is the network working group, and they provide the informational things that to define what happens in the different protocols for networking itself. The next authentication protocol, Kerberos, which if you listen to Microsoft, you think they owned it, they invented it, and they were the only ones that used it, but it was developed by MIT. It is designed for mutual authentication and encryption on insecure networks. Insecure networks would be our Ethernet networks, would be our wireless network. So what this is another one that sends hashes across, hashes of the passwords with a salt, to create a more difficult method of trying to break the password. I won't say, well, we can say crack the password. They're not, since they're hashes, they're not unhashed. We simply create a bunch of hashes till we find one that matches the one that we have. Used in Windows domains, it's also used by Linux, and it's used widely for single sign-on systems. The authentication server is a trusted third party. The realm is the basic network unit, although in Windows we're going to call it a domain. A realm you probably would hear in the Linux world. A principal is a node belonging to the realm or a node belonging to the domain. And then we have the key distribution center, the authenticating server, and the ticket granting server. I've got some images here in a couple of slides. Actually, a couple of slides have images on what this process works like. Kerberos started being used by Windows with Windows 2000. Before that, it used the NTLM in order, new technology land manager in order to do authentication. So ever since Windows 2000, Windows has used Kerberos for the authentication protocol. A multiple step process, and when you look at it, say, boy, this is the most confusing thing in the world, and it kind of is, and it kind of isn't. So the first thing that happens is the client authenticates with the authentication server. You know, that would be what we normally do. The authentication server gives a ticket granting ticket. It sends a ticket granting ticket back to it, and the client presents the ticket granting ticket to the ticket granting server. And then the ticket granting server grants a ticket for these things. The client requests a resource, and then they present the ticket. The ticket that you get has all of your authorizations in it. And this is kind of one of those, when you get it back, maybe this one's a little bit, probably not as in focus. I try to make it a little bit bigger, but the logon here, the key distribution center, the authentication server, and the ticket granting server are normally all on the same server. They're on the domain controller in the Windows Active Directory. So this one, we send a username, I am user Sue and need a ticket to get tickets, ticket granting ticket. And it says back, here is a ticket granting ticket if you can decrypt this response with your password hash. So it encrypts the ticket granting ticket with, or hashes it with, our password. And this is how, you know, the password gets checked or used or sent or not sent across the network. So then Sue sends her ticket granting ticket to the ticket granting server, requesting a service ticket. The service ticket has a list of all of the resources that we can get to. So here's the service ticket. When you go to a resource server, you present your service ticket, which says what you can use and what you can't use for the domain or the realm, whichever term we're going to use with these things. So kind of a long, I guess, winded process. In NTLM, every time you went to get a resource, you had to be authenticated. In this one, you're only authenticated once, and you can, as a network administrator, you can specify how long the tickets are good for, and I think the default is something like 15 hours. So, and once the time's up, they just simply get renewed. So the way we do that, the Kerberos key exchange or ticket exchange, the way Kerberos gets eventually the service ticket gets presented to the resource servers so that we can access resources on the network. And this is resource services within the domain. LDAP, Lightweight Directory Access Protocol. There was a DAP, a Directory Access Protocol, but it was so complex and so big that they had to shorten it. It was developed by one of the browser authors that no longer exists, and the name's not coming to me. But it's a simplified version of an X.500 Directory Access Protocol. X.500 is, again, it's like the RFCs. It is a definition of everything that has to be inside of a true, complete directory access protocol, the directory access protocol. LDAP doesn't quite get there, and Active Directory doesn't quite get there. The only one that actually ever complied, or if they're still in business, and they've gone mostly to the rest of the world, is NetWare. Their directory service was X.500 compliant. It had all of the elements. Active Directory has basically two tables that it uses. It looks like an X.500 directory, but it's really not got the depth that one has. But the LDAP uses port 389, centralized access to a database with network information. There are a lot of LDAP databases. You used to be able to use them, look them up on the internet with some of the browsers. I haven't tried that lately, but I'm not sure that the new browsers will actually support those. Queries can be used in scripts, sent as URLs. Active Directory uses LDAP and Kerberos in order to do its authentication. So Kerberos is doing the exchange. LDAP is the directory service that allows us to get the information. I was trying to get who built it. Anyway, I will. But LDAP, intended for trusted networks. There is an LDAP secure. It uses port 636 for those. So we have an LDAP and a secure LDAP for these things. These are a couple of single sign-on protocols, the XML-based Security Assertion Markup Language. And I think they just call it SAML, in order to simplify things. It's an XML-based single sign-on. Some of the places that use it are Google and Salesforce. And again, Google, there are lots of places that you can authenticate with Gmail, you can authenticate with Facebook, you can authenticate with Twitter. And I don't think LinkedIn's got into it yet, but they may. So this may be the protocol that's being used there. Mini authentication, it allows multiple authentication mechanisms to get there. This one says authentication to the identity provider and then the identity assertion to the service provider. Kind of what happens here, Google would be the service provider. So we start here with the user. The user tries to reach hosted Google application. Google redirects the browser to the SSO URL, the single sign-on URL. The browser then redirects to the SSO URL. The partner parses the SAML request, authenticates the user, generates the response, sends the response, partner returns the encoded response to the browser, and then the browser sends the response to the ACS to the ACS URL, the services URL that we're trying to get to, and then the user is logged in to the Google application. So single sign-on, like a lot of the things that we've seen, multiple players involved in it. There's lots of communication that takes place. OAuth is open authentication. Does not handle the single sign-on authorization. Kind of a similar process that we saw a little earlier. This is open authorization. We have the Memorial Bank over here. We're trying to get onto the Bank My Bucks application. So we send an authorization request to the authorization server. Here and up here, Sarah is the name that's sent there, and whatever other things, usually going to be a username and password. Although some places are actually using key fobs now to get into places that you need high security, banks and brokerage firms, those kinds of places. So it sends an authorization grant. The application then sends the authorization grant back to the authorization server. And this is going to be kind of like Kerberos uses. We got one that says, oh yeah, here you are. If you can decrypt this, that's good, and it sends it back. Then we get the access token, which would be like the service ticket for Active Directory. The access token is then used to get to the resources on the resource server. So a separation process that's used here for the open authentication.